In this video, we want to determine the derivative of a logarithmic function. So we'll begin with y equals log base a of x, and we'll take this equation and rewrite it in exponential form. This will give us a to the power of y is equal to x. So now we're going to take the derivative of both sides of the equation with respect to x, which means we're using implicit differentiation. So this will be the derivative of the left-hand side with respect to x, and the derivative of the right-hand side with respect to x. Now, fortunately, we know the left-hand side, we know the derivative of an exponential function. So the derivative of a to the y power will be a to the y times the natural log of a, and then we'll chain on the derivative of y with respect to x, dy dx. And on the right-hand side, the derivative of x with respect to x will just be 1. And finally, we'll go ahead and solve for dy dx by dividing both sides by a to the y power times the natural log of a. So our dy dx is equal to 1 divided by the quantity a to the y times natural log of a. But if we look back up in our work, we notice that a to the y power is actually equal to x. So we can go ahead and substitute out our a to the y and replace it with x. And this gives us a nice formula for the derivative of any logarithmic function, which is 1 divided by x times the natural log of a. So moving on, we can fill in our derivative formula, 1 divided by x times the natural log of a. And then we can use this formula to help us figure out the derivative of natural log of x. So remember, natural log of x is really a logarithm with a base of e. So if we think about taking the derivative of log base e of x using the formula that we just came up with, that would give us 1 divided by x times the natural log of the base, and in this case our base is e. But remember, the natural log of e is actually equal to 1. Therefore, this derivative simplifies to be just 1 divided by x. So the derivative of natural log of x is simply 1 over x. Now let's use these two new derivative rules to practice finding the derivatives of these logarithmic functions. So question A is y equals log base 2 of the quantity 2x minus 3. And we'll notice that this is a composite function. So our outer function is log base 2 of some unknown function, and our inner function is 2x minus 3. Therefore, we're going to go ahead and use the chain rule to compute the derivative of y. So the derivative of log base 2 of something will be 1 over our argument times the natural log of the base, and in this case, the base is 2. Then remember, our inner function is 2x minus 3, so we're going to substitute the 2x minus 3 into the derivative of the outer function. And then we have to remember to chain on with multiplication the derivative of the inner function, and the derivative of 2x minus 3 is just 2. So my simplified derivative will just be 2 divided by the quantity 2x minus 3 times the natural log of 2. And remember, it's super important that you have 2x minus 3 in parentheses because that entire quantity will get multiplied by the natural log of 2. Example B, our function is f of x is equal to 5x times natural log of x. So we notice we have a product here. When we're multiplying the quantity 5x times natural log of x, the 5 is just a constant multiple, so I'm going to think of the 5x as my first factor and the natural log of x as my second factor, so I'm going to use the product rule here. So utilizing my product rule, we start with the first function, which is 5x, and we multiply that by the derivative of the second function, which is natural log of x. The derivative of natural log of x, we just figured that out, that's 1 over x. Plus the second factor, or the second function that's being multiplied, which is natural log of x, multiplied by the derivative of the first. The derivative of 5x in this case is just 5. So this derivative simplifies pretty nicely because we notice that the x's will divide out, so we'll be left with just 5 plus 5 times the natural log of x.